Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientist with me, Sue Marchant, and Dave Ansell. How's the world of science with you?
I saw an interesting story this week. I don't know if you've ever noticed a spider's web in the morning and the way they're covered in droplets of dew quite often.
Yes.
Well, some Chinese scientists have been looking into why this is, because actually spiders' webs are particularly good at collecting dew.
Yep.
And they looked at the web of a Japanese spider, and if you look very carefully at the web, it's not just a single. It's not a single string. It's got lots of little bumps in it.
Yeah.
And what happens is droplets of water seem to form on these bumps or around these bumps, and slowly get moved in towards the bumps, and the droplets get bigger and bigger and bigger until you get big lumps.
Right.
Lovely big droplets, which you can see and look wonderful in the morning sunlight. Now, that might seem, okay, that's kind of pretty, but why would it be useful? But there's lots of times when you're trying to collect water from the atmosphere. Mm-hmm. There's various places, like in Bolivia, where there's lots and lots of damp air coming in from the sea, but it never rains. Mm. So already the locals have strung up lots of bits of string to collect dew in the morning, and they can collect it for drinking water. And if you can improve that and get structures using spiderweb technology, in fact, they've managed to make an analogue of it using plastics.
Wow.
You might be able to collect water even more efficiently using kind of fake spiderweb strung across the hillside.
That's amazing. That's amazing. So there is sense in science sometimes.
Quite often, I think.
Now, Dave, an email here from Brian in Wisconsin, USA. Hello, Brian, and thanks for emailing in. Dave, I understand that perpetual motion cannot exist. What I can't figure out is, why is the Earth able to continue spinning? Also, I understand the gravitational force between large objects, but then why is the Moon drifting away from the Earth at a rate of 3 centimetres per year?
Well, there's several questions there. The first one was how the Earth can keep spinning. Now, a perpetual motion machine it's not just something which will keep on going forever. What a perpetual motion machine is something which will keep on going, and you can keep taking out energy from it forever. So often they're crazy designs whereby you have a car which has a windmill on the top and the windmill powers the car, and they never work because every time you convert energy from one form to another, you tend to lose some to heat or sound or something, and slowly you lose energy and the thing dies relatively quickly. That's not to say that if you can make something with low enough friction, it can't effectively keep on going forever. Or not necessarily forever, but very close to forever if the friction is almost zero. And the Earth is very, very, very heavy, and it's surrounded by vacuum, so there's almost no forces on it, and so it can keep on spinning for a long, long time. The Earth its spinning is slowing down very slowly. It's actually due to the tides. We know it's slowing down because if you look at corals from the seas sort of 200 million years ago, and each day the coral grows slightly more, so you get layers, so you get daily sort of tree rings in these corals. Yeah. And in the summer they grow fast in the winter, so you can work out how many days there are in a year by looking at how many sort of coral rings there are in the summer bit, then in the winter bit, then the summer bit, then the winter bit, and there were 400 days in a year 200 million years ago. And we think the year stayed the same length, but just the Earth is now spinning slower than it used to. And the reason is because of the tides. The Moon's gravity is pulling on the water, and the water has got lots of friction with the Earth, so the Moon is effectively pulling on the Earth, and so the Earth is slowing down very, very slowly over hundreds of millions of years. Now, that also means that because Isaac Newton worked out if you push something, there's always an equal opposite reaction, so it will push you back. So if the Moon is pulling on the Earth and slowing it down, then the Earth must be pulling on the Moon and speeding it up. So the Earth's rotation energy is being transferred from that into the Moon, and so the Moon's getting more energy, and so it's orbiting further away, and so the Earth is slowly moving further out because of the tides.
Wow, that's really quite something. All right, let's go to our questions that are here. Mike in Colchester says we're all going digital very soon. Is the rest of the world doing the same, and what will happen to the analogue waves? Dave?
Okay. A lot of other countries are going digital, definitely TV. America's going digital with TV, similar sort of time to us. I think a lot of the rest of Europe are kind of moving along slowly. And TV, it's quite easy because TV is intrinsically an expensive thing, and the digital box inside it isn't that expensive compared to the TV. Radio, it's a bit more hit and miss, I think. I think France and Germany, they're all trying to go, definitely all the developed world is trying to go digital because you can get more channels in the same amount of space. I think France and Germany are having some issues with people getting take-up, and they're getting less and less certain they're going to turn off the sort of FM radio as well. And what's going to happen to all the AM waves or the analogue waves? I mean, basically, there's a whole lot of frequencies there. You have lots of different frequencies. What they want to do is turn them into digital frequencies so you can get more digital radio stations, I think, is the plan. How many digital radio stations you need, I don't know, but that's what they want to do. Or they could use them for other forms of communication. Whoever wants them, really. I expect there'll be an auction at some point if we manage to go entirely digital, and whoever pays the most will get it.
All down to money. How scary is that? This time, Alex has sent an email in with a physics question. Alex is from Milwaukee. Crikey. What an international audience we have this evening. Thank you very much. I've got a physics question. I've always wondered how much less we weigh because the Earth is so large size-wise. I took intro physics, and in one semester I learnt about vector forces and gravity in the same month. Basically, my thought is that because we're on the surface of the Earth, some of the gravity is pulling us left, right, forward, back. But if we were standing on a bowling ball having the same weight as the Earth, it would all be pulling us down with no waste. I can't figure out how to solve the problem, and I suspect I need to learn some more maths. I'm absolutely lost, Alex.
Okay. Luckily, we don't have to do the maths because we can use something which Isaac Newton actually worked out 300-400 years ago. He worked out that the way gravity works, if you do all the maths and you add up all the forces from every lump inside a sphere, as long as something is spherically symmetric, so you can rotate it in any direction, it always looks the same, so planets are approximately spherical. If you've got a sphere, then the gravity from it is the equivalent to having all of the mass at a point in the middle of it. And therefore, it looks, once you're outside the sphere, the gravity all looks the same. So, and the gravity is an inverse square force. So if you half the distance, the force quadruples. So a bowling ball has maybe got a radius of about 6.5 centimetres. The Earth has got a radius of about 6,500 kilometres. That means that the bowling ball is about 100 million. I think in my very rapid calculation, the bowling ball is about 100 million times smaller than the Earth. Which means if you're standing on the bowling ball weighing the same as the Earth, the force would be 100 million squared, so 10,000 million times stronger than it is when you're standing on the surface. If it was smaller, it would keep on getting bigger and bigger and bigger. The forces would get bigger and bigger and bigger. So yes, the forces would be absolutely immense if all the Earth's mass was in the centre of a bowling ball.
Mike has called in to say about Blu-ray. How is it so different from the normal DVDs that we buy? Is it a new concept or just an improvement of what we already have? So the difference between Blu-ray and the DVDs that we have. It's just a way to get us to buy another player or something, I suppose. But Dave, what do you make of it?
Okay. Basically, CDs, DVDs and Blu-ray are all working on the same principle. You have a sheet of aluminium, very, very thin foil of aluminium, with little pits in it, and then you fire a laser at these pits, and either the laser and the way the laser bounces off changes depending on whether there's a pit or there's not a pit. So you can store information by essentially sort of coding it up and then either putting a pit in somewhere or not putting a pit in. So if you look at the surfaces with a really good electron microscope, you see lots of little pits, and all the music, all the film, all the video is stored in patterns of these pits. The difference between them is basically the size of the pits. A normal CD, the pits are bigger and they use red lasers. When you want to get the pits much smaller than a normal CD, then red lasers, the wavelength of the red light is longer than blue light, so it doesn't. So in fact, you couldn't use a red laser to get smaller than that. So they have to use blue lasers in DVDs and Blu-rays. I think Blu-rays might, although I'm not entirely sure, they might even have stored data on more than one level, although I'd have to look into that. It's definitely something people have been talking about for a while.
Wow. So
you can focus at different depths and get more information out.
Oh, now then, on the text, Mike has said, now that Mr. Obama pulled the plug on return to the moon, will there be any spectacular space events and big rockets?
I think it depends. There's certainly Not building very, very large rockets. They're not intending to, or certainly not the US government isn't intending on building very large rockets. What I think they want to do is try and get private companies to start making rockets, because the theory is that governments tend not to be very efficient and they tend to waste lots of money, whereas a company who's very determined to make the rocket as cheap as possible, because then they make more money, is probably going to end up building rockets cheaper. There's certainly if the price of getting things into orbit gets lower, then lots of things become a lot more possible. There will be the kind of people going off into space for touristic purposes, which would be quite fun, but not really, I don't think, what he's thinking about. I think there'll be lots and lots of robotic missions to other parts of the solar system. There will be some very big telescopes which will probably find planets like the Earth, possibly even find evidence for life in another solar system, which would be absolutely fascinating and make the whole world think slightly differently, I think.
If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast. OK, all right, let's go on to our next question. It is from Dave, who sent an email in. He said, what are the white streaks left down the windscreen after the windscreen wipers have done their jobs? Is this water from the washer bottle, as rainwater does not leave streaks? Is it?
I would have thought so. Rainwater shouldn't leave streaks, because basically streaks are something which has been dissolved in water, and as the water evaporates, whatever's dissolved in it, there's no water left to hold it, so it just kind of gets deposited. So one of the classic ones of these is limescale. If you live in an area like around here where all the water's coming out of chalk or limestone, it basically dissolves limestone in the water. And then if you let water evaporate, you basically get a sort of chalk left over. So if you're filling your washer bottle from water from the tap round in East Anglia, then there will be lots of white deposits from basically limestone depositing out limescale. The other things it could be is dust. If your car's going to get dust dropping on it all the time, it's going to be picked up by the windscreen wipers, and if then their water evaporates away, it's going to get deposited along in the same place as the limescale. So I would have thought, yes, it probably is water from the washer bottles and maybe a bit of dust mixed in.
Now then, what are the chances of winning the lottery jackpot twice? Is it currently 140 0,000,000 to 1 to win it once? And Dave in Great Yarmouth says, speaking of 6 lucky numbers, recently the Belgium lottery produced the same numbers on repeat draws. What are the chances of this happening, and what is the formula to calculate this? I'm getting my pound ready here. Go on.
Probability is an interesting subject. If I was to play the lottery twice in a row, the probability of me winning once, I think, is 1 in 14 million. And then the probability of me winning again would be 1 in... Every time I play it, there's 1 in 14 million chance of me winning.
Right.
So the first time is 1 in 14 million, and the second time would be 1 in 14 million. So the total probability of me winning twice in a row would be 1 in 14 million times 14 million. So 196 million. OK, so that's really low. But if someone's already won the lottery, then you're starting from a different position. You've already won it once, so the probability of winning it again is the same as anyone else, 1 in 14 million. The other question was, what's the probability of getting the two numbers the same in a row?
Speaking of 6 lucky numbers, recently the Belgian lottery produced the same numbers on repeat draws. So it did it on the 6th of September and the 10th of September.
OK.
What are the chances of this happening? So
basically, the first number you've got isn't lucky. It hasn't taken that. You always get a number, so there's nothing special about that first number. So the probability of getting a number in the first week is 1 in 1, because you're always going to get a number unless the place explodes or something. The probability of getting the same number again is just like you filled in your lottery card with the numbers from last week, and you play it again next week. So that's going to be on the UK system, 1 in 14 million. I'm not sure how the Belgium lottery works. It could be a bit lower, it could be a bit higher.
Yeah.
1 in 4 million I think someone mentioned, sounds about right. And then it's to do with how many weeks you've been running. So if it's been running 10 years every year, that then means you've had 500 chances of winning twice in a row. So then it's maybe 1 in 4 million divided by 500. So it was maybe 1 in 8,000. So the odds get better the longer it's been running. If it's been running for 100 years, then it would be 1 in 800. Quite unlikely, but there are a lot of lotteries in the world, and there's a lot of, and very few of them that happened. So it doesn't necessarily mean that it was faked.
Excellent. All right, Dr. Dave, thank you very much. Chris Simcox has texted in and said, I've read that magnetic north and south could flip. Is this true? And what would happen to the human race? From Chris.
Okay. The Earth's magnetic field can flip. It does flip. It's flipped many times in the past. It sort of flips every few tens of thousands of years. In fact, that's how we know that's how we found out that the Earth's oceans are changing size and growing and shrinking. Because if you look at the bottom of the magnetic field locked into rocks, because various volcanic rocks lock in the Earth's magnetic field, which is there when they were created. If you look at the magnetic field produced by those rocks, if you go across the Atlantic, in some places it points north, then it points south, then it points north, then it points south, and it points north. This is because the Atlantic is growing slowly. And as it grows, sometimes the North Pole magnetic pole is at the north, and sometimes it's at the south. And it's been flipping over thousands of years, again and again and again. And you can see it sort of fossilised in the ocean floor. It does flip. It's flipped inside the time when humans have existed, so it certainly hasn't killed us off completely. What effects would it have? The Earth's magnetic field actually protects us from cosmic rays. These are little particles, charged particles, moving incredibly fast, thrown off by the sun and from things outside the solar system. And these crash into the Earth's magnetic field. They get trapped by it, and then they crash into the sky, upper atmosphere in the north and south poles. Because if you imagine a bar magnet, that's where the field comes down to Earth. And that's why you get northern lights in the North Poles and southern lights in the South Poles. And so if you had so when the Earth's magnetic poles flip, then everything becomes all a bit confused. You actually have more than one North Pole, more than one South Pole, probably. And so you get particles kind of coming in all over the place. These could cause a bit more cancers. They could do various things like that. You get big issues with power supplies because you can induce these Earth's magnetic field changing very rapidly with these solar storms. Can induce great big currents in power supplies, and it actually knocked out a big solar storm knocked out the Canadian power grid for a while because it induced big DC currents around it, which it's not designed for, and it broke. It might well interrupt communications. It would make life difficult for computers. It would basically make our life difficult. It wouldn't kill us off, I think, is the answer. It would make high technology slightly less efficient, but we'd probably live through it.
Let's hope not. Our next little one here says... it's from Jason in Woodbridge. To Dr. Dave, how are certain materials transparent?
The very simple answer to that is they don't happen to absorb any light at the optical frequencies. Most materials are transparent at some frequency. So that basically means that it's got no way of absorbing light of a certain energy. Different colours of light have different energies. At the red end, they've got lower energy. At the blue end, they've got a higher energy. For something to absorb light, it has to be able to absorb the amount of energy in a single packet of light, in a single photon of light. Some substances just don't have any way of absorbing energy over certain energy amounts. Some substances don't have any way of absorbing certain amounts of energy from certain colours of light, and so they're entirely transparent to those colours. So glass is transparent in the optical region, but it's opaque, but it can absorb in the ultraviolet and in the infrared. So yeah.
All right. Will has sent a email in here talking about moles. Right. I know that 1 mole of hydrogen is 1 gram, and 1 mole of oxygen is 16 grams. Does that make sense to you?
1 mole of hydrogen atoms, yeah.
So would, in a perfect reaction, 1 mole of hydrogen bond with 1 mole of oxygen to form H2O, or 1 mole of hydrogen to 2 moles of oxygen? I'm lost.
Okay.
Thank you, Will.
Moles are basically a convenient way of doing calculations for chemists.
Yep.
Basically, they're on the idea that, for example, if you react hydrogen with oxygen to make water, you need two hydrogen. It's actually H2. H2 means two hydrogen atoms to one oxygen atom. So you need twice as many hydrogen atoms as oxygen atoms in order to make a water molecule. So if you want to know how much chemicals to mix together, you want twice as many hydrogen atoms as oxygen atoms. It's slightly more confusing because hydrogen comes in pairs and so does oxygen. But you still need twice as many hydrogen molecules as oxygen molecules.
Okay.
And then you could do this by working out the total number of atoms of hydrogen in your bucket and the total number of atoms of oxygen in another bucket. But that gets kind of difficult because the numbers are very, very large, because there's about 6 with 23 zeros of it atoms of hydrogen in 1 gram of hydrogen. So that just involves writing an awful lot of zeros, and it's hard work. So chemists, they can't be bothered with all the zeros. So they just say that we'll invent a number which is so that 1 gram of hydrogen, we'll call it a mole, and 1 mole of hydrogen weighs 1 gram. If the atom is heavier, like oxygen atom is 16 times heavier, so 16 grams of oxygen equals 1 mole. So you've got the same number of atoms in each. So 2 moles of hydrogen react with 1 mole of oxygen to give you 1 mole of water.
Phew. Pat from Lowestoft, she's asking, Dave, do you believe there is life out there, other life out there?
I would be very, very surprised if there wasn't any other life out there. I'm pretty certain that there is sort of simple life out there. There's probably quite complicated life, sort of things like sort of jellyfish and mice and things. And again, somewhere in the universe, there's probably and almost certainly has been intelligent life. But whether it's close enough for us to ever find, that's a whole other question. Because the real critical thing is, how long do intelligent species last? Because humans have only really been intelligent for maybe a few tens of thousands of years. We've only been able to communicate with other civilizations for 50. And it's all possible that we might wipe ourselves out in the next 50 years. So if intelligent species only on average last for 100 years, the odds are we'll never find another one. If on average they last for 1 million years, then we probably will.
Right, one from Brenda here in South Africa. It's an email. I would like to know if boiling water changes its composition. I heard that plants which were fed from natural water lived, and that those that were fed boiled water, if it is allowed to cool, died in the composition of the water change while it was boiling. So the plant did not recognise the liquid water and died. Interesting question. So does it change?
Water will change a bit when you boil it. The big difference is you will drive off any dissolved gases. So it will drive off dissolved sort of oxygen, and it will dissolve carbon dioxide and things like that. And this is why boiled water tastes slightly funny. It kind of tastes very, very flat and sort of tasteless compared to normal water. It's because you've driven off all the water, all the carbon dioxide. And you're used to it tasting slightly fizzy, actually, because of the dissolved carbon dioxide. And so it does change a bit. Should it affect plants? I would be very, very surprised. Apart from anything else, if water sits near the atmosphere for very long, it will reabsorb all of those gases after 2 or 3 hours sitting out there, and it's going to be sitting on the bottom of a plant, so it might do. Something which might make a difference on a plant, if it wasn't boiled water but distilled water. So you've boiled the water and then recondensed it somewhere else. That will take out any dissolved minerals. So normal water's got things like dissolved calcium and dissolved magnesium in it. And distilled water won't. Plants need magnesium, they need calcium, they need minerals. I could believe there are plants which could survive on normal tap water, which has got some minerals in it if you don't give it any soil, but they wouldn't survive on distilled water. But just boiling water, it doesn't make a big difference to it.
All right. Malcolm in Lowestoft says, talking about life in space, I thought about this in great depth. And if you think about the mathematical number of planets, it would be extremely conceited if you thought there was nothing else out there. But we do think there's something else out there, don't we, Dave?
I think that's basically my point of view.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.